and welcome to more special limits. So in a previous video, we saw that trig functions and exponential functions, natural log, we could solve by simply evaluating. We also saw that if we had rational functions, as long as the denominator did not go to zero, if we had division involved, quotients involved, as long as the denominator did not go to zero, we could just go ahead and evaluate the two limits and then divide. If we look at these limits I have in front of me, a lot of these limits are going to cause problems in that sense. So the limit as x goes to 0 of sine x over x, the top and the bottom here would both go to 0. So we have a 0 over 0 situation. And usually if we do 0 divided by something, we'd get 0. But we also know that when we divide by 0, we go to infinity. So we have a 0 and an infinity messing with each other. It turns out that this limit itself is actually 1. So while the top going to 0 would tend us towards 0 and the bottom going to 0 would tend us towards infinity, it turns out they kind of balance each other out and we wind up going to 1. There is a proof of this in the textbook. So there is a proof of this. In section 1.3, which you can look up. We will also learn an alternative method for evaluating this called L'Hopital's rule later. So we will also learn something called L'Hopital's rule further on in the semester. Which will allow us to evaluate this limit quickly. So it will give us another method other than just memorizing the facts. Cosine x minus 1 over x. Well, as x goes to 0, the denominator is definitely going to 0. Up top, cosine x would go to 1, subtract 1. That numerator is also going to 0. We have a 0 over 0 situation again. We have a 0 going to 0 and going to infinity, fighting with each other. It turns out in this case, the top overrules, and we actually go to 0. So essentially what we're looking at here is we're looking for which one is going to 0 faster. If the numerator goes to 0 faster than the denominator, then our limit will go to 0. If the denominator goes to 0 faster, then our limit will go to infinity. And if they balance each other out, then it could hit any other number. This next one, the limit as x goes to 0 of 1 plus x, all raised to the 1 over x. Well, as x goes to 0, the inside here would go to 1, and the exponent would go to infinity. Now, typically 1 raised to any power will stay 1, but numbers close to 1 will blow up if we use high enough powers. So that exponent of infinity is trying to make our numbers blow up to a large number, while the thing inside is trying to stay at 1. What happens in the end is this actually winds up being E, that weird number E that we've seen before. And then finally, limit as x goes to 0 of e to the x minus 1 over x. E to the x is going to 1. Subtract 1, this numerator will go to 0. The denominator goes to 0. We're in a 0 over 0 situation. And we want to know which will go to 0 faster, what's going to overrule. It turns out that this limit also winds up simply being 1. So again, at this point, these are just limits that you should memorize. Later on in the course, we will learn L'Hopital's rule and other methods, which will give you a method to evaluate these if you forget the facts. But for now, these are our special facts for 4 very special limits as x goes to 0.